Hello, welcome to question 90 of this exam practice medley. A lot of people have requested I demonstrate this question. So here it goes. So it's worth 5 marks, but the amount of work involved and the knowledge that you need probably I would say should be worth a lot more marks, but there's a possibility where this question may not be answered by many. So if they put too much marks, then that leaves the people very little opportunities. So in fact, this is your opportunity to achieve distinction if you make sure that on Monday 2020 in January, this exam you attempt this. So this is a typical question to get you to solve forces using trigonometry, and also to be able to resolve forces vertically and horizontally. So you have to do both. So it's asked, what this is saying is this plate here, you see, is in static equilibrium. That means this force, and this force all produce a force which keeps this stationary. So it doesn't fall over that way or fall over this way, or it doesn't get lifted up. So therefore the question is, what is the magnitude of this force and what is the direction of this force from the horizontal? So it's given you the theta, and that's what we need to find out. The magnitude is basically the force F. Okay, so let's start with, and this is exactly what you need to start off with, by saying resolve vertically all the forces. So you look at each of the forces and find the vertical component. Now just like moment, where you have the equal sign and you put all the sum of the clockwise moment equal to the sum of the anti-clockwise moment. Now because this is not a turning moment, so therefore the forces on the left should either be all of your vertical upward component, or this will be all of your vertically downward component add together. So you can see, so let's first notice and identify that this component here is just purely vertical upwards. So I can put 200 Newton on the left hand side. So the question is, what is the vertical component for this force? Well, the arrow is go from this here to here. So therefore, to go from here, I have to go horizontally that way, followed by vertically downwards. So this is a downward vertical component, so it should be written on this side. So, and I can do the same for here. So it's go from there to there. So therefore, the horizontal component will go to the right first, then it will go downwards like that. So therefore, it's also going to be on this side of the equations. So someone asked me, so sir, how do you find out what the vertical component is for this one when it's got no numbers? Well, that's where trigonometry comes from, and you is applied here. And you could be really quick because you're doing an exam, there's not a lot of time. So this is a little trick, because you're given an angle 66 and you want to know this, and so it's the opposite. So whenever you have the opposite and hypotenuse is sine. So straight away, because you only sine the angle, so what you do is you put your hypotenuse multiplying like so. And so this one, again, this is the theta, so it's opposite. So this vertical component is going to be theta and F, because that's the hypotenuse. So we can have, it's again is opposite, so therefore it's a sine. So F sine theta. Okay, so So you might say, well, so how can we solve this equation if there's two unknown? Well, don't worry, just keep that as a one term. So what I will do is I'm going to make this as a subject of the formula. So I can write f sine theta is equal to 200. Throw this to the other side, minus 200 sine 66. Put that in a calculator. You will find that f sine theta is equal to 17.29. So you pause at this point, and now you're going to go and resolve vertical components. Horizontal component. So now I'm going to resolve the horizontal component. So you might think, wow, 5 marks for all this work. Well, this is not actually that daunting at this point, because there is no vertical, there's only vertical component and there's no horizontal. So basically, you are going to resolve this one and this one. So because one is left, one is right, so you got to put left on one side and right on the other side, just like you did the here, vertical up this side, vertical down all on this side. Okay, so because we've just done the opposite, this must be the adjacent, so all of them here must be the cos. So therefore for this one, it's straight away I can write 200 cos 66, and this side I can write so once again is f, this time cos theta, or in other words, f cos theta is equal to 200 cos the 66. Okay, so what do we do with the next part? Well, luckily you've just okay, sorry, I forgot to mention, put that in the calculator, you're gonna get 81.35. Okay, so the magnitude is simply, therefore, it's just this and this using Pythagoras, if you remember in lessons. So the magnitude force is going to equal to the square root of 17.29 square at 81.35 square. And once again, the calculator will inform you that the magnitude F is going to be equal to 83.17 Newton. This is the answer for this computation. So, I mentioned earlier on, this is a little bit tricky, and this is the moment now, so pay attention. So, how do we find the angle? Well, this is something that you might not have been taught in GCSE maths, but certainly in A level, both maths and physics, we need to recognize that sine theta over cos theta is actually tan theta. So what I could do is I could divide f sine theta by f cos theta. So I can write f sine theta over f cos theta. So what you do to this, you must also do the same to this side. So therefore, that equal to what's f sine theta? 17.29 is over f cos theta, 200 cos 81.35. So because f and f will cancel out, and that leaves you with sine theta over cos theta, which means that is tan theta. So in fact, this is not so difficult to remember, that sine theta over cos theta is tan theta. So just remember that you only learn sin cos tan at this possibly at this level, and so therefore, if you do sine over cos, it's going to give you tan. Okay, so and then I've got this, and you all know that in order to find theta, I have to throw tan on the other side, which means I have to put tan in on this side as an inverse function. So therefore theta is equal to inverse tan bracket 17.29 over 81.35, and put that in the calculator, and that should give you 12.00 degree to 2 decimal place. And so the theta is 12.00 degree. Okay, so that's how you do it. So once again, step 3 is probably the one that you need to pay a lot more attention to, and make sure if you got to this stage and you don't know what to do to find theta, is basically you need to put it into a fraction form like that in order to force this to become a tan theta. So that's how you do it. Okay, thank you.